Hello guys, welcome back to my channel. Today we're gonna solve LeetCode problem 141, linked list cycle. This is an easy problem. Let's just go through the description once. Given head, the head of a linked list. Determine if the linked list has a cycle in it. So we have to find if there is a cycle in a linked list. Okay. There is a cycle in a linked list if there is some node in the linked list that can be reached again by continuously following the next pointer. So if we are traversing next pointer and eventually we reach back to a node, then like we can conclude there is a cycle in it. Internally, a POS is used to denote the index of a node that tail's next pointer is connected to. Note that POS is not passed as a parameter. So as a developer, we don't have knowledge about POS when we are designing the code. This is just for the explanation they have given POS. Okay. Return true if there is a cycle in the linked list, otherwise return false. Fine. Let's just go through one of the example. Uh, Here we have a linked list 320 minus 4 and POS is 1. So basically they are with this information they are giving us an idea that last node of a linked list is pointing to the index 1 of a linked list, that is 2, the value 2. So minus 4 is pointing to 2. Since there is a cycle, it's giving output as true. There is a cycle in the linked list where the tail connects to the first node, so 0 indexed. Fine. Rest of the examples are similar. Nothing new. Let's just go to constraint ones. The number of node in the linked list is in the range 0 to 10 raised to power 4. Okay, so 10 raised to power 4, this gave us an idea that we had to solve this problem in O of n complexity, under O of n complexity, um, like O of n or equal to or less than. Yeah. Mm, the approach I can think of in here is, so what all things can we do in linked list? The first thing is we can traverse, we can add, we can remove, but there is no point in adding or removing anything, like any of the node. uh, so using traverse, what we can do? Mm, 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 mm. There is, yeah, if we are traversing, there is one way. I remember a tortoise hare algorithm. So tortoise hare algorithm is like, it's basically two pointer. In two pointer, what we are doing is, the first pointer is pointing to the first element and second pointer is pointing to the last element, and like in each iteration we are incrementing the first pointer and decrementing the last pointer. So same thing we can do with the linked list, but in here instead of pointing instead of pointing the second pointer to the last element, we can point both the pointers to the first element. uh yeah, we can point both of them to the first, and uh, what we can do in here is we can we can assign speed of first pointer as like second pointer, we can assign a speed of second pointer as twice as first pointer. So to be clear, like what's gonna happen is first pointer will be iterating, in each iteration it will be moving one node, but whereas second pointer will be moving two nodes. So first pointer is a slow pointer, it's moving like a tortoise. Second pointer is a fast pointer, it's moving like a hare. So what advantage we have with this algorithm is, eventually if there is a cycle, they are gonna like meet at one spot. So eventually they're gonna meet at one particular node, which will indicate that okay, there's a cycle. That's the reason they are meeting on a same spot. Else what would have happened? So if this was a linear linked list, there was no cycle. Eventually minus 4 will be pointing to null. So if in the first iteration 3 was pointing to 2, like in the first iteration 3 will be pointing to 2, slow pointer will be pointing to 2 and fast pointer will be pointing to 0. But in the second iteration slow pointer will be pointing to 0, but whereas fast pointer doesn't have any other node, so it will point to null. So eventually it will reach null. So like if the pointers are reaching null, we can say there's a linear link, that's a linear linked list. But if there's a cycle, again we can iterate it for the cycle. In the first iteration slow pointer will point to 2 and fast pointer will point to 0. In the second iteration slow pointer will point to 0, whereas fast pointer will move 2 steps, so it will go to 1. In the third iteration slow pointer will point to -4, whereas fast pointer will point to -4 as well. So eventually they are meeting at the same node. Then we can conclude, okay, there's a cycle in it and we can return true. So this is the logic for a tortoise hare algorithm that we can use in here. So let's just code this. So we can start with declaring two variable, two pointers, fast and slow. Initially both are pointing to head. We can create a loop. Here we'll be checking for fast dot head. So as I explained earlier, if fast pointer or the next pointer for fast, like if uh, if they are pointing to null, then we can conclude that's a linear linked list. Don't have to iterate it, we can just end the loop and return false, as it will conclude that it's a linear linked list. It's not a there is no loop in it. uh, but if it's not failing, then we'll go in and declare slow as we are moving slow with one like in one iteration slow will move one step, whereas fast will move in one iteration it will move two steps. Next. Yeah. So if both slow and fast is pointing to same node, then we can conclude there's a cycle in the linked list. We can return true, whereas here we can return false. This will conclude that it's a linear linked list. There's no cycle in it. Let's just try run this and see if it passes our test cases or not. So yeah, our test cases are getting passed. Given test cases are passed. Let's submit it and see if it passes the hidden test cases as well. Okay, it's passing the hidden test cases. Although our solution time complexity is not that great, it's beating only 33.57% submissions. But I think it's acceptable. Okay. Mm, okay, that's it for today, guys. We'll see you tomorrow. Thanks.